Hello viewers, we're now taking you through the story of A-level pure mathematics. And in this video, we're going to go through the marking guide of Senior 5 Math Paper 1 of mid of Term 2 for the year 2023. So this video is suitable for students in both Senior 5 and Senior 6 offering principal mathematics as part of their combination. So our program this month will be based on past papers. So my interest is to upload videos on the past papers, and those will include mid of term exams, mid of term 2, and mock exams, and also U.A.C.E exams. So most of you have been asking for the U.A.C.E of last year, the marking guides, and now is the time to plan and upload them. So they are uploaded bit by bit until they are all done. So that is our program for this month. So we have begun with mid of term 1, mid of term 2, and we have begun with math paper 1 of Senior 5. There are some resource books which may be of good help if you are in A-level. So if you're for principal mathematics, there are 4 books: Math 1, Math 2, Topical Question Bank, and Termly past papers. Then for physics, there is Physics 1, Physics 2, Topical Question Bank, and its solutions. For subsidiary math, it is only 1 book. So to get a copy, you can contact the author on this contact or send a WhatsApp message. So now we can begin with our paper of Math 1, mid of Term 2 for the year 2023. Section A had 6 questions. That means it was not standard, and it was out of 30. Remember, a standard paper contains 8 questions of Section A, which is out of 40. So because the coverage is still a little low, we chose to give 6 questions in Section A. And question 1 says, solve 2 to the power 2x minus 3 multiplied by 2 to the power x minus 4 equal to 0. So the first thing to do is to realize that this can be expressed in terms of 2 to the power x. So let's make 2 to the power x be y. That means that this becomes y squared, because this is the same as 2 to the power x, everything raised to the power 2. Which gives you y squared. Then this is 3 is here, and 2 to the power x is y, as we have said here. This minus 4 equal to 0. So now we have got a quadratic equation, and you can either solve it by factorizing or by quadratic formula. But of course, quadratic formula is a little easier. So this is the quadratic formula: negative b squared plus or minus b squared, which is here, minus 4ac. I think we are conversant with that quadratic formula, divided by 2a. So after that, we shall get 2 values of y. There is y equal to negative 1 and y equal to 4. But remember, the question had x, so you have to bring back the x. So when y is negative 1, 2 to the power x is equal to negative 1, implying that x is undefined. But when y is equal to 4, 2 to the power x is the same as 2 to the power 2, implying that this base cancels to remain with the powers, where we come up with 2x equal to 2. So those are that is the value of x which they wanted. So 1 mark would be for getting this quadratic equation, solving it, both values of y, then saying this y that x is undefined, 1 mark, and saying this x equal to 2, that's another 1 mark. So that's how you could get the 5 marks in question 1. Then question 2 says the roots of the equation this are alpha and beta. Find the values of 1 over alpha plus 1 over beta, and values of alpha squared plus beta squared. So first of all, from this, first thing to do is to make this coefficient positive 1 by dividing through by 3 to give you that. Then from there realize that the sum is negative of this, which is negative 4 over 3, and the product is the whole of that, which is negative 5 over 3. But this is what was given in the question, so go and get the LCM, then substitute. Numerator is sum, which is this, and denominator is product, which is that. So when I change this division sign into multiplication sign, this becomes reciprocal, and in the end we come up with 4 over 5. For Roman 2, this one is the same as alpha plus beta squared minus 2 alpha beta. It's a known formula. Then come and substitute for sum and the product, then use a calculator to get the answer they want. So 1 mark would be for both this sum and product, 1 mark for the substitution, 1 mark for the output, 1 mark for substitution, 1 mark for output, and that's how the 5 marks would come about. So what disturbed most students is this negative. Some of them, they were just writing 4 over 3, which makes everything not okay. Then question 3, find the equation of the line through the point 2, 3 and perpendicular to the line this. So perpendicular lines, we know that the product of their gradients is equal to negative 1. So come at this given line and write in the form of y equal to mx plus c, which is this. So this is m and this is c. That means that the gradient of this line is negative 1/2. But for perpendicular lines, the product of their gradients is equal to negative 1. So substitute for m1 and get the gradient of this line, which is perpendicular to the given line. So that gives us m2 as 2. So now that we have the gradient of the required line and a point on that line, we can get the equation of the line which they want. You can either start from y equal to mx plus c and substitute for y, m, and c. Sorry, y, m, and x. Then get the value of c, and after that you can rewrite this to give you the equation of the line they wanted. Alternatively, you can choose to equate gradients. So change in y over change in x is equal to 2, which is this. Cross multiply and get the output. So 1 mark was for this gradient, another mark for this gradient, another mark for substitution, intercept, and required equation. So that's how the 5 marks would come about. So most students could not recall this, and that led to loss of many marks. Most of the students here in substitution for m, they are using negative 1/2, which is not okay. Question 4 says, given that 3 plus 2 log base 2 of x is equal to log base 2 of y, prove that y is equal to 8x squared, and hence find the root of the equation this. So we shall first rewrite the given equation, then we look for of eliminating logarithm. First we shall combine the logarithm. So this goes this side to give you x squared. Then take this side to give you this. And subtraction, when you're combining, it becomes division. So it becomes y over x squared. Then from there we shall remember that 2 to power 3 is equal to y over x squared. They have eliminated the logarithm. Then cross multiply to get the required expression. So for the hence part, they wanted to solve this to find the root of that equation. So we shall come and first write it. Then remember that the whole of this is equal to this. So I'll come and substitute. Why there was this, I'll put there log base 2 of y. Then from there, remember that y is equal to 8x squared. So I'll come and substitute. Why there was y, I'll put there 8x squared. Then from there, I realize that this is same base. So log base 2, log base 2. So it can cancel to remain with this. And this can be rearranged to get a quadratic equation. And this equation can be solved using the quadratic formula to give you two values of x which they wanted. So one mark was from there, another mark was the required x proof, then quadratic equation, solving it, and the both outputs. And that's how the 5 marks would come about. Then question 5 says the sum of the first n terms of a geometric progression is this. Find the nth term as an integral power of 2. So this is the expression for the sum of the first n terms, meaning the sum of the first term, you replace where there is n, you put 1 to give you 4 as the first term, as the sum of the first term, which is the sum of the first term, and sum of the first two terms, where there is n, put there 2 to give you 20. So that means that first term is this, and second term is done by subtraction, s2 minus s1 to give you 16. Then because it's a GP, there is a common ratio, so divide second term, divide by first term to give you the common ratio. Then they want the nth term. Nth term is AR at power n minus 1. So come and substitute for A and for R. So this one is the same as this, where this 4 can cancel to remain with 4 to power n, which is 2 to power 2n. And that's what they wanted, integral power of 2. So one mark was to get the first term, second term, common ratio, substitution, and output. And that's how the 5 marks would come about. Question 6 says, differentiate x squared plus 2x from first principles. The first thing to do is to let y be equal to that. Then increment both sides. So y is incremented by small change in y, and x is incremented by small change in x. Then expand. This expanded gives you x squared plus 2x small change in x plus small change in x squared. Then this expanded gives you 2x plus 2 small change in x. Then remember that y is the same as that. So the reason why you do that is because we want to make small change in y the subject. So take this y this side by substituting this. Then from there realize that something cancels. This cancel. So I'm going to remain with small change in y equal to this, this, and that. From there, we want to divide to get small change in y over small change in x. So divide through by small change in x. So this divided by small change in x gives this. This one divided by small change in x gives that. This gives this, and this gives that. Then you realize that this and this can cancel. This and this can cancel, and also this reduces by 1. So remain with small change in y over small change in x being equal to 2x plus small change in x plus 2. But they want us to differentiate. They want you to get the y dx. So the y dx is the limit as small change in x tends to 0 of small change in y over small change in x. So this one, replace it with this to give you that. Then for this limit to be removed, it means that where there is small change in x, put there 0. Because it tends to 0. So it gives you that. And that's what they wanted. So one mark was for incrementing, another one mark was to make small change in y the subject, getting small change in y over small change in x, substitution, formula or definition for the y dx. So this word has to be seen, and this is the output. Then question 7, now we have begun section B. So section B still, it had 4 questions. And that's why you see a 48 marks, each with 12 marks. So question 7 says, on Alice's 11th birthday. Note this one, they didn't say first. Most students took this as first birthday, which is not okay. They took it as 11, so it is 11th birthday. She started to receive an annual allowance. So it is on the 11th birthday where she began to receive allowance. So some students, when they saw this, they thought this was the 11th allowance. It is not okay. So 11th birthday corresponds to first allowance. Okay, then she says the first annual allowance was shillings 500,000, and on each following birthday the allowance was increased by shillings 200,000. Part A, Roman 1 says, show that immediately after her 12th birthday, the total of the allowances that Alice had received was shillings 1,200,000. I think let's begin with that. So I think we realize that if this was an increment, it becomes a common difference, implying that this is now an arithmetic progression. So I shall come and say that total allowance, this is for the first, then 11th birthday, and this is for 12th birthday, because I said it's increased by 200. So initial, which is A, plus D, to give you the final answer as that, and that's what they wanted. Then Roman 2, they said, find the amount of Alice's annual allowance on her 18th birthday. So that means that n is equal to 8. Because 11, n was 1. 12th, n was 2. Now 18th means n is 8. So you'll come here and say this is A, this is D. Therefore, on the 18th birthday, n is 8. So nth term is A plus n minus 1D. So come and get the T8 which they want, which is 500 for A, then n is 8, D is 200 to give you 1.9m. So that was Roman 2. Then Roman 3 says, find the total of the allowances that Alice had received up to and including her 18th birthday. That means they want the sum of the first 8 terms. So the formula for sum of the first n terms of an AP is this. Therefore, come and substitute for n is equal to 8, A is 500,000, n is 8, D is 200,000. So in the end, you come up with 9.6 M. And that will be the total they wanted. So this one, M for substitution, B for output, M for substitution, A for output, M for substitution, A for output. So that's how we could get the 6 marks in part A. Then when you go to part B says, when the total of the allowances that Alice had received reached shillings 32 million, the allowance stopped. Find how old Alice was when she received her last allowance. So sum of the first n terms is 32 million. So come and substitute for Sn equal to 32. Then substitute for A and for D. So now we have only one unknown, which is n. So expand and simplify by dividing through by 100,000. Then get a quadratic, which can be solved from the quadratic formula to get the two values of n. But n cannot be negative, so it's negative. N cannot be negative, implying that n is positive, which is 16. But remember, they began counting on the 11th, so it means that the earliest age will be 10 plus 16, which is 26 years. So this M of substitution, quadratic formula, solving, conclusion. Conclusion means you eliminate the negative. Substitute, addition, and output. So that's how we could get the 5 marks in this part. Question 8 says the expression this gives a remainder 11 when divided by this and a remainder negative 21 when divided by this. Find the values of a and b and hence factorize the expression. So here I shall let this expression be equal to fx, meaning that for this x minus 1, x is equal to 3. Therefore, come and substitute for x in this expression to give you that. Where there is x, you put 3. And equate to the remainder, because they told us the remainder is 11. Therefore, you get an equation having two unknowns, which is a and b. Do the same for this other one. For this one, x is negative 1. So where there is x, put there negative 1 and equate to the remainder, which is negative 21. And simplify to get an equation 2. So you have two equations and two unknowns, meaning you can solve them simultaneously. So before we solve them simultaneously, let's first look at the marks which should be got in the slide. This will be for substitution and equating to 11, equation 1. Substitution and equating to negative 21, equation 2. Now we are going to solve the two equations simultaneously. Equation 1 minus equation 2 gives for a equal to 48. And when I divide 12 by 4, I'll come up with a as 12. After getting a, I'll come and say that from equation 2, substitute for a and get the value of b, which is 20. Therefore, our fx is this. Where there was a, we shall put b, we have put 12. And where there was b, we shall put 20 to get our fx. Now they told us to factorize. So to factorize, you have to get the factor. And when I substitute 2 in this equation, I'll get 0, meaning that x minus 2 is a factor. After getting one factor, I can either use long division or synthetic method. We shall look at both methods, but let's start with synthetic division. So synthetic means first write the coefficient of x cubed, x squared, x, and the term independent of x in that order. Then write here the root, which is x equal to 2. Okay. Now from there, we're going to get this 6 and put it here down. From there, multiply this with this to give you 12, and that's what you'll put here. Then you're going to repeat the procedure. This plus this gives this, and this times that gives you negative 22. Repeat the procedure. This plus this gives you this, and this multiplied by 2 gives you negative 20. So these two, when you multiply, add them, we come up with 0. So what is here is what they call remainder, and in this case the remainder is 0 because there is 0 here. So another method is called long division. For long division, what you do, this divisor is what you put outside here. Then this function is what you put inside there. Then for long division, you divide highest power by highest power. So highest power of the function divide by highest power of the divisor. So this divided by this gives you 6x squared. Then from there, multiply this through this to give you this. After that, we are going to subtract. So when I subtract the 2, I'll come up with this. Then from there, I'll repeat the procedure, this divided by this to give you negative 11x. So negative 11x multiplied by x minus 2 to give you that. Then again subtract to give you negative 10x plus 20. So again this divide by this, you come up with negative 10. So negative 10 times x minus 2 gives you that. So subtracting gives no remainder. So now this one is what will give us the other two factors of this fx. So come and look for factorizing it. You are going to look at two factors whose sum is negative 11 and product is negative 60. So those two factors are negative 15 and positive 4. That is why where there was negative 11, I've replaced it with negative 15 and positive 4. Then I'll pair this alone and this alone to factorize out what is common. For this first one, 3x is common, so remain with 2x minus 5 in brackets. For this other one, 2 is common, so remain with 2x minus 5 in bracket. Then after that, I'll make realize this and this are common, meaning that this with this gives us the other factor. And from there, we can now write our factors of fx being where the first one is this, and the other two are these ones which have been got from this quotient. And that is how the 8 marks would come about from the slide. So now we shall go to question 9. Question 9 part A says, Stanley invested £200,000 in business at a compound interest of 15% per annum. Find the time to the nearest year it takes to reach more than £600,000. So first we shall quote the formula for compound interest, amount for compound interest, then we shall substitute. So P is that, R is that, and they say that this amount should X to be more than. So more than, that's why we are using the word inequality sign of greater than. Then from there we shall simplify. This 200 goes this side, become 3 when you divide. So 600,000 divided by 200,000 gives you 3. Then this one becomes 1.15 raised to the power n. Then shall introduce the logarithms and take everything on the logarithms on one side to get n greater than 7.8606. But they said nearest whole number, nearest year, so it becomes 8. That was part A. Part B says, prove by induction that this is equal to this where n is a positive integer. So before we do that, this is how the marks will be allocated for part A. So for part B, we are going to first state the series, and then we test for n equal to 1 and n equal to 2. So n equal to 1, it means first term for the left hand side, and substitute 1 where there is n in the right hand side. So they are equal, meaning it's true for n equal to 1. N equal to 2 means 2 terms for the left hand side, which gives you 5, and for the right hand side where there is n, substitute 2 to give you 5. So it is true for n equal to 2. Now suppose, so when it comes to n equal to k, we just suppose it's true for n equal to k, the series becomes that. We have got this by replacing where there is n, we have put k, n put k, n put k, n put k. So that slide, those are the 2 marks. Then for the next slide, we shall see what happens when n is k plus 1. So when it's k plus 1, it is better you start with the right hand side. I think realize previously we were starting with left hand side, then right hand side. But for this, it is advisable to start with the right hand side. So right hand side means you go back here And where there is n, you put k plus 1, k plus 1, k plus 1. So that's what gives us this. Simplify to come up with this. Then on the left hand side, it means you add on the next term after n equal to k. So that next term comes from here where there is n, you put k plus 1. That is why we are saying this word k plus 1 squared. But now from here, you'll get it from the assumption, because you already made this assumption that 1 squared up to k squared is the whole of this. So that means that you are coming back to this, and where there is from here up to here, it will be replaced by what we got in the assumption. Then get LCM. There is 6 here. Then from there, factorize out k plus 1, k plus 1. They are common. Factorize it out. Then expand this box bracket to give you this, which is this. And after that, we are going to factorize. So you look for factors whose sum is 7 and product is 12. Of course, that will be 4 and 3. That is why you see where there is 7k, I've put there 4 plus 3. Then from there, I'm going to factorize by pairing this alone and this alone. So this alone, 2k is common. So factorize it out, remain with k plus 2. Then this alone, 3 is common. Factorize it out, remain with k plus 2. So now we have k plus 2 and the remainder will be 2k plus 3, which is here. Now I think realize that this and this are the same, because we have 1 over 6, which is this. We have k plus 1, which is this. K plus 2, which is that. 2k plus 3, which is that. So because left hand side is equal to right hand side, then it is true for n equal to k plus 1. And therefore can now make our conclusion that since it is true for n equal to 1, n equal to 2, n equal to k, and n equal to k plus 1, then it is true for all positive integers of n. And that's what they wanted. So B1 for getting this right hand side, M1 for this substitution, B1 for factorization, this for replacing. So this part has to be seen from here to here. Then B1 for expressing this in a format which is similar to right hand side. And this B1 for conclusion. Then question 10 part A says solve the simultaneous equation. Then they give you this. So you can either use substitution or elimination, but for this video, I shall use elimination method. So I'm going to first call them by equations. The first one is equation 1, equation 2, equation 3. Then from there, I will say that if I want to eliminate A, I realize that there is 2A here and here there's just A. So to make them the same coefficient, I have to multiply this equation 2 by 2. That's why you see here 2 times equation 2. So equation 1 is this, equation 2 multiplied by 2 gives you that. Then you subtract, this cancels, this minus this is negative 11b, this minus this is negative 3, this minus this is 16. So that is equation 4. Then I also eliminate A from equation 1 and equation 3 to give me this as equation 2. So now I have 2 equations now and 2 unknowns. There are 2 marks here, meaning that I can subtract the 2 to eliminate B and get the value of C. Out again the value of C, I can either use equation 4 or equation 5 to get the value of B. So what I've used is equation 5, not 2. Here we call it equation 5. So B will be equal to negative 2. Then from equation 2, I can get the value of A. And that's what they wanted in part A. Now we shall go to part B. Part B, they said, given that the equations this and this have a common root, show that this is equal to 0. So let the common root be alpha. It means that where there is x, we shall put alpha. Those are the two equations now. First, I'm going to eliminate alpha cubed by multiplying alpha through equation 2 to give you this, then subtract to get this. So in this equation, I've eliminated alpha cubed. The next will be to eliminate alpha squared to get the value of alpha in terms of C. After getting alpha in terms of C, I can now substitute in n of this to get the required expression. So M1 for solving, A1 for value of C, value of B, value of A. M1 is eliminating alpha cubed, eliminating alpha squared, and making alpha the subject. So I come and substitute it in equation 2, and x cross multiply, open brackets, for this gives you that, this 2 gives you that, and this gives you that. The next is to simplify. So simplifying, I come up with what they wanted. And that's how we could get the 3 marks in the slide. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on marking guide for math part 2 of senior 5 mid of term 2. So if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.